Imagine an invisible, impenetrable shield protecting our entire planet from the deadly, chaotic radiation of the cosmos. Now imagine a massive, expanding void forming directly within that very shield. This is not a science fiction scenario. Right now, a colossal anomaly is growing in Earth's magnetic field, and the world's leading space agencies, including NASA, are monitoring it with a profound sense of urgency and concern. Welcome to a deep dive into one of the most unsettling phenomena occurring right above our heads. If you value understanding the hidden forces that shape our world, ensure you subscribe and stay with us until the end. To comprehend the gravity of this situation, we must first understand the invisible armor that surrounds our planet. Deep beneath the Earth's crust lies a churning, turbulent ocean of molten iron and nickel. This outer core acts as a planetary dynamo, generating a complex magnetic field that extends far out into space. This magnetosphere is absolutely critical for our survival. It deflects the constant bombardment of solar wind, cosmic rays, and lethal radiation emitted by our sun and distant supernovas. Without it, our atmosphere would be stripped away, and Earth would become a barren, irradiated wasteland, much like Mars. However, this protective barrier is neither uniform nor static. Scientists have identified a vast, expanding region where this magnetic shield is significantly weaker than anywhere else on the planet. This region is known as the South Atlantic Anomaly, or SAA. Stretching from the coasts of South America across the southern Atlantic Ocean to the shores of Africa, this massive dent in our magnetic field allows dangerous solar particles to penetrate much closer to the Earth's surface. For the average person walking on the ground, the thick layers of our atmosphere still provide adequate protection. But for anything operating in low Earth orbit, the SAA is a treacherous hazard. Why is NASA so deeply concerned? Because our modern civilization relies heavily on a delicate infrastructure of satellites. When spacecraft, including the International Space Station, pass through the South Atlantic Anomaly, they are subjected to a severe bombardment of high-energy protons. This intense radiation can cause catastrophic glitches in onboard computers, corrupt vital data, and permanently fry sensitive electronic components. The Hubble Space Telescope, a pinnacle of human engineering, is literally forced to shut down its most delicate observing instruments every time it transits this hazardous zone to prevent irreversible damage. Several satellites have already been lost entirely due to radiation spikes in this specific area. The mystery deepens when we investigate the root cause of this anomaly. Seismologists analyzing acoustic waves traveling through the Earth's interior have discovered massive, dense structures deep within the mantle, resting just above the outer core. One of these colossal blobs is situated directly beneath southern Africa. Researchers theorize that these dense, localized formations are actively disrupting the flow of the molten iron, essentially short-circuiting the geodynamo in that specific region. This disruption at the boundary of the core and mantle is directly manifesting as the weakening magnetic field thousands of miles above in space. Adding to the complexity, recent satellite data has revealed that the South Atlantic Anomaly is not just weakening and expanding, it is actively mutating. The anomaly appears to be splitting into two distinct separate lobes, creating a dual-threat environment for orbital mechanics. This unpredictable evolution makes it exceptionally difficult for space agencies to model the radiation environment and protect their multi-billion-dollar orbital assets. But the implications extend far beyond satellite damage. Many geophysicists believe the SAA could be the early warning sign of a much larger, planetary-scale event, a complete geomagnetic pole reversal. Throughout Earth's geological history, the magnetic north and south poles have swapped places hundreds of times. The last major reversal occurred approximately 780,000 years ago. We are statistically overdue for another. During a reversal, the global magnetic field doesn't disappear completely, but it becomes highly fractured, chaotic, and significantly weaker. If a massive solar storm, similar to the infamous Carrington event of 1859, were to strike Earth during this weakened state, the results would be devastating. It could induce massive electrical currents in our global power grids, causing catastrophic blackouts, destroying transformers, and crippling global communications. We are talking about potential damages reaching into the trillions of dollars, plunging modern society into darkness for months, if not years. NASA, the European Space Agency, and scientific institutions worldwide are deploying swarms of specialized satellites to continuously map the Earth's magnetic field and monitor the South Atlantic anomalies' every movement. Understanding the deep mechanics of our planet is no longer just academic. It is a matter of global security and technological survival. As we continue to rely on fragile technology, the invisible forces beneath our feet dictate our future. Thank you for watching, and do not forget to like and subscribe for more essential insights into our incredible world.